Let's take a look at an example when we try to check whether a function is continuous at a point. We have to check all three conditions because they are conditions when a function is continuous. So condition number one is the function defined at the point that we're interested in. So x equals 0. Okay, so is f of 0 defined? According to this piecewise function, when x equals 0, f of x equals 1. So it is defined. Number two, do we have a limit? So is limit as x approach 0, f of x, does it exist? Well, how do we calculate this limit? You see, when x equals 0, the function equals 1. But when you talk about the limit, you really need to look at the variable piece, okay, when x is not 0. So you are really checking whether this limit as x goes to 0, sine of x over x, is this piece have a limit. And we have learned from the squeeze theorem, this limit equals 1. So the limit exists and it equals 1. And this is one of the special limits you need to memorize. So in step 1, we see that the function is defined. And in step 2, we see that the limit exists. And the limit equals 1. Okay, so now we can move on to step 3 because it haven't failed any condition yet. So do we have this limit as x approach 0, f of x equal to the function value f of 0. So what is f of 0? F of 0 equals 1. What is the limit as x approach 0? According to this special limit, it also equals 1. So we do have condition number 3. So we have the function defined, limit exists, the limit equals the functional value. So our conclusion is f of x, this piecewise function, is continuous at x equals 0.